Time travel is a staple of science fiction, but is it possible? Some scientists believe the answer is yes. Join us as we look at the science behind the most popular theories of time travel and what they might teach us about our universe. Light speed. Einstein taught us that space and time intertwined in a vast cosmic dance are relative. They depend on the observer's frame of reference and are not absolute. This means that time is not constant and can be manipulated. One way this can happen is by traveling at near light speed. According to Einstein's theory of special relativity, time slows down for an object as it approaches the speed of light. This means that an astronaut who travels at 90% of the speed of light would experience time more slowly than someone who remains on Earth. This phenomenon, known as time dilation, was confirmed in the 1970s by experiments with atomic clocks on airplanes. While these were only small differences due to the relatively low speed of the planes, the effect would be much greater on an intergalactic spaceship traveling at closer to the speed of light. So if an astronaut were to travel at 90% of the speed of light for 10 years, upon returning to Earth, they would find that less than 9 years have passed. Traveling faster would result in even greater discrepancies between the time experienced by the traveler and that of people on Earth. However, there's a catch. Traveling at such high speeds requires a tremendous amount of energy. As an object approaches the speed of light, its mass increases significantly, making it harder and harder to accelerate further. Also, there is currently no known technology that could propel a spacecraft to such high speeds. For now, traveling at near light speed remains just a sci-fi fantasy. But as technology advances, who knows what may become possible? Wormholes, portals, through space-time. Wormholes are another fascinating concept in physics that has captured the imagination of scientists and science fiction fans alike. Theoretical physicist Albert Einstein first proposed the idea of wormholes in 1935, building on the work of mathematician Ludwig Flamm. Despite their intriguing nature, wormholes remain purely hypothetical and have never been observed. A wormhole is essentially a tunnel that connects to distant points in spacetime, allowing for travel between them. If wormholes do exist, they could potentially serve as gateways for time travel. However, the scientific community is divided on whether wormholes are merely mathematical curiosities or actual physical phenomena. Proponents argue that wormholes could be the key to understanding the behavior of matter at the subatomic level, and may hold the secret to time travel. Others are more skeptical, pointing out that wormholes are highly unstable and require exotic forms of matter to keep them open. Furthermore, there are concerns that any objects entering a wormhole would be destroyed by intense gravitational forces, making them unfeasible for interstellar travel. Despite these challenges, researchers continue to explore the possibility of wormholes and their potential implications for our understanding of the universe. Cosmic strings, one-dimensional defects in spacetime. Cosmic strings are hypothetical one-dimensional defects in spacetime that are thought to have formed in the early universe during phase transitions. These thin, incredibly dense threads of matter would have been stretched out to great lengths and could potentially be used to travel through time. The idea of cosmic strings was first proposed in the 1970s by Italian physicist and cosmologist. While cosmic strings remain purely hypothetical, some astronomers believe that they may explain certain observed phenomena in the universe, such as the cosmic microwave background radiation and the large-scale structure of galaxies. If cosmic strings do exist, their immense density could warp the fabric of spacetime and create closed time-like loops. These loops would allow for the possibility of time travel. However, it's unclear whether these hypothetical time machines would be practical or safe. It's also unknown whether cosmic strings would have enough mass to significantly impact the evolution of the universe. Further research is needed to determine the role of cosmic strings in the formation of the universe and whether they could potentially be harnessed for time travel. Tipler cylinder, infinite cylinder with a ring of matter. The Tipler cylinder is a theoretical device proposed by physicist Frank Tipler that could potentially be used for time travel. Unlike other time machines, it doesn't rely on wormholes or exotic matter, but rather uses a long, thin cylinder filled with a ring of matter rotating at near light speed. The cylinder is infinitely long, with a ring of matter extending along its entire length. When rotated, the ring of matter creates a massive gravitational field that warps the fabric of spacetime. This warping creates a closed time-like loop at one end of the cylinder, allowing for the possibility of time travel. However, there are significant challenges associated with creating a Tipler cylinder. It would require an enormous amount of energy to rotate the ring of matter at near light speed and maintain its stability. Additionally, The cylinder must be perfectly smooth, with no bumps or irregularities that could disrupt the flow of time. Despite these challenges, the Tipler cylinder remains a fascinating theoretical concept for those exploring the possibilities of time travel. Further research may reveal whether such a device could ever be constructed and used to manipulate the space-time continuum. Theories of retroactivity. Another approach to understanding time travel is to question the very nature of cause and effect. What if events don't occur in a strictly linear fashion, but rather multiple timelines intertwine and influence each other? This theory, known as retroactivity, suggests that events in the past can influence the future, blurring the boundaries between cause and effect. Supporters of this view argue that the universe operates more like a complex web, connecting all moments in time and allowing for the possibility of time travel. However, retroactivity poses significant challenges for our understanding of physics and the laws of nature. If events in the past could influence the future, it would violate the principle of causality, which states that cause must precede effect. This could lead to a host of paradoxes, such as the grandfather paradox, where a time traveler goes back in time and kills their grandfather, thereby preventing their own existence. To resolve these issues, some theorists have proposed the many worlds interpretation of quantum mechanics, which posits that every time a decision is made, or an event occurs, the universe splits into multiple parallel timelines. In this scenario, time travel becomes a journey to a different universe rather than a trip to the past or future. While retroactivity remains a controversial and speculative idea, it offers a thought-provoking perspective on the nature of time and the interconnectedness of events. Further exploration of this concept may lead to new insights into the mysteries of the universe and the boundaries of human understanding. Black holes. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape their grasp. They form when massive stars collapse at the end of their life cycle and are characterized by their immense density and powerful gravitational pull. The boundary of a black hole is known as the event horizon, which marks the point of no return. Once something crosses the event horizon, it cannot escape the black hole's gravitational pull, and is inevitably drawn towards its center, known as the singularity. Black holes play a significant role in the universe and are thought to be responsible for the formation of galaxies and the large-scale structure of the cosmos. They also provide a unique opportunity to study the behavior of matter under extreme conditions. Black holes have a profound impact on our understanding of physics and the nature of reality, challenging our preconceived notions about the laws of the universe and the limits of human knowledge. By studying black holes, scientists hope to unlock the secrets of the cosmos and gain a deeper understanding of our place in the grand scheme of things. Time machines. While time travel remains a captivating concept in science fiction, recent advancements in physics have brought us closer to unraveling the mysteries of time and the universe. From the mind-bending theories of relativity to the exploration of wormholes, cosmic strings, and retroactivity, scientists are pushing the boundaries of human understanding to explore the boundaries of the cosmos and the nature of time itself. Whether time travel will ever be possible remains an open question. But the pursuit of this goal has led to countless discoveries and insights into the fundamental workings of our universe. As technology continues to advance, who knows what wonders and revelations await us in our quest to understand the infinite complexities of space and time. Thank you for joining us on this journey through the fascinating world of astrophysics. If you enjoyed this video, please subscribe and stay tuned for more updates on the latest discoveries and theories that are shaping our understanding of the cosmos. Don't forget to like and share for more updates. Until next time, keep looking up and exploring the wonders of the universe.